M1 Kinematics Example 19. So in this question, we've got a particle moving along a straight line. The particle accelerates uniformly to a certain speed, travels at a constant speed, and then decelerates. And we're asked to sketch a speed-time graph. When they use the word sketch, it just means it doesn't have to be to scale. So we're accelerating uniformly from rest. When we're accelerating, that's a positive gradient. We then travel at a constant speed for a certain length of time. And then the particle decelerates uniformly to rest. To rest means that the velocity is 0. Okay, so let's put some labels on our diagram. So it accelerates uniformly from rest to a speed of 8. So this first section is to 8, and that takes t seconds. Travels at this 8 meters per second for 5t seconds. So our total up to here now is 6t. There was t seconds there, and a further 5t gives us 6t. And then it decelerates for a further 40 seconds. So this little stretch here is 40 seconds. Okay. So that's part A. It now tells us that the total distance travelled by the particle is 600 metres. Now we know 600 represents the area underneath the graph. So that's our clue to help us with part B, where we have to find the value of t. So we've got a trapezium here. Again, you could treat it as two triangles if you wanted to, and a rectangle, but I'm going to do that trapezium formula again. Okay, we just need to be really careful with our lengths here. So it's a half. Now, A is the short side usually. Now, that was t, and it travelled for a further 5t to get us to 6t. So this length here at the top is 5t. Now, what is this length along the bottom? Well, we had t, then another 5t, that got us to 6t, and then another 40. So the whole length along the bottom will be 6t plus 40. 6t up to there, plus another 40. And h is 8. Now we know that when we work that out, our answer will be 600 because they've told us the distance. So let's do a little bit of simplifying. The half and the 8 can multiply together to give 4. And then inside the bracket, 5t and 6t is 11t. And then we've got plus 40. I could multiply out the brackets, but I think it will actually make the numbers smaller if I divide both sides by 4 at this stage. So 11t plus 40, divide by 4, that would give us 150. Subtract the 40, I can see that someone's engineered this question nicely. So 11t is 110, so we get a nice round number. T is 10 seconds. It doesn't always work out that nicely. So find the value of t, we've done that. So t here is 10, 6t, that will be 60, and so the whole period of motion actually takes 100 seconds. Okay, so part C says sketch an acceleration time graph illustrating the motion of the particle. Well, if we think about what's happening at the beginning, the particle is accelerating. So in the first phase, the particle has an acceleration, and remember that's given by the gradient. The gradient is change in y, which is 8, over change in x, which is 10. So it's got a gradient of 4/5. In the middle section, the acceleration is 0 because the velocity is constant. And then in this latter section, the particle is decelerating. The change in y is -8 because it's coming down by 8. And the change in x is 40. And that works out to be -1/5. So we've worked out our 3 accelerations. So I've already prepared some axes down here at the bottom. So in the first section, the acceleration is positive. Then the acceleration is 0. And then the acceleration is minus a fifth. Now, the first one was 4/5, and this is 1/5. I'll try and make it look a quarter of the height that that one is. Okay. These lines are horizontal because it's a constant acceleration. So just to label up the axes, vertically it was 4/5, which is 0.8. So that was the first section of motion, 0.8. Then it was 0, and then it was minus 1/5. A fifth is 0.2, so minus 0.2. We should also label the time. So if you remember, t was 10 seconds. Then it travelled for another 5t, so that'd take us up to 60 seconds. And then another 40 seconds, so that'll take us up to 100 seconds in total. So that's the acceleration time graph there in part C.